STI Engineering is an engineering firm located in Southern California, specializing in landfill engineering by using state-of-the-art methods such as the piezo penetrometer test, or PPT, to create a 3D profile of a landfill's current conditions, such as the image being presented here. Based upon the findings of several landfill investigations and the review of proposed bioreactor applications, Reg Renault, the owner of STI, developed and patented the steam injection bioreactor process. STI uses the PPT data to identify potential problem areas of a landfill and then develops the best approach to return that landfill to compliance. This approach was also used to perform a pilot study at the Miramar landfill for the city of San Diego in California. The permits were issued in May of 2005, and the project was performed over the next 10 months. The goals of the pilot study were to determine how well steam can migrate through waste, determine if the steam can heat up the waste prism, can a bioreaction be sustained and will the landfill settle, recovering valuable airspace. Another goal was to determine if gas generation could be increased and controlled using the steam process. STI achieved all of their project goals during this pilot study. STI used the following procedures to perform this pilot study at the Miramar landfill. A site investigation was performed on the selected portion of the landfill. The selected area for the study was prepared, and the steam injection system was installed using STI's state-of-the-art methods. Upon completion of the pilot study, a final PPT investigation was performed, and the results were reported to the governing agencies. The pilot study was performed on a portion of the landfill that did not have any gas collection influence prior to the study. A PPT profile was performed on approximately 4 acres of the landfill. 18 PPT soundings were performed across this area. Based on this data, 1 acre was selected for the pilot study. Some of the soundings were pushed to 80 feet below the landfill surface. Once a dense soil layer was identified at the 52-foot depth, the remaining soundings were terminated at about 55 feet. A 20-ton cone truck was used to perform the PPT profile of the test cell. The PPT cone measures several parameters while it is hydraulically pushed into the landfill. This data was used to determine the extent of the vacuum influence of the nearby existing gas collectors so that the test cell was outside this influence. The PPT verified that we did not have perched water layers within the test cell. It also verified that a dense soil layer or traffic deck was located at 52 feet below the surface of the landfill. This layer was used as a false bottom of the landfill to detect any accumulation of liquid from the steam process. The waste was actually 140 feet thick in this portion of the landfill. Various PPT contractors present their logs differently. This is the typical PPT log. Note the 30 feet of liquid indicated in this sounding. This sounding was not performed at this landfill. The test cell was prepared by removing the erosion protection mulch from the cover soil so that the surface could be monitored for stress cracks as the landfill began to settle. The cover soil was 8 feet thick over the test cell, and it is believed that it may have inhibited some of the settlement due to bridging. The test cell consisted of 6 landfill gas extraction wells, 3 steam injectors, 9 thermocouples, and 2 static piezometers. There were also 5 settlement monuments installed to monitor settlement during the test. A control cell was created adjacent to the test cell, which consisted of 2 gas extraction wells and 1 settlement monument. This was used to compare the effects of the steam injection process in the test cell. 3 steam injectors were installed down the center line of the test cell, running north to south to a depth of 35 feet. 3 gas extraction wells were installed along the east side of the test cell, and 3 were installed on the west side. Their depths range from 35 to 37 feet deep. The spacing was about 100 feet from each other. The PPT truck is usually used to install the gas extraction wells and the steam injectors. However, this contractor's rig could not perform this task. For this installation, a geoprobe type rig was used. A PPT sounding was performed at each location for the injectors, as well as the extractors, so that there is a full depth log of the current conditions. The PPT rig was used to pre-punch the well and injector locations prior to installing the pipe casing. The 2-inch diameter steel pipe with 1/8-inch mill slot screens were installed in 5-foot-long segments. As the landfill settles and a 5-foot blank segment becomes exposed, this segment can be removed and the steam line is reattached. The bottom 20 feet of the injectors were slotted. To monitor the migration of the steam through the waste prism, 9 thermocouples were installed into the landfill at various depths and at various distances from the steam injectors across the test cell. The PPT rig was used to install these instruments. The thermocouple wire was pre-threaded into the cone rods as they were pushed into the landfill. A thermocouple was also attached to each of the steam injectors. These thermocouples were connected to a scanner that records the temperatures. An on-site trailer was used for data acquisition and equipment storage. The PPT rig was also used to install 2 static piezometers at the north and south sides of the test cell at a depth of 52 feet to monitor any accumulation of liquids on the dense soil layer. A flush joint casing was pushed into the landfill to the desired depth. 3/4-inch PVC pipe was inserted down the casing and a sand filter was installed as the casing was removed. The bottom 5 feet of the piezometers were slotted. No liquids were ever indicated in these piezometers. This is an overview of the completed installation of the steam injection process for this pilot study. This is the control area. One of the main challenges during this study was the lack of leachate and condensate. Only about 1/3 of the water that was required for this test was available. This restricted the steam operation basically to a daylight schedule. It is believed that if the steam operation was allowed to run 24/7 with no cool-down period, settlement could have tripled. However, it was discovered that on days that no water was available, some portions of the test cell would sustain the temperature at 120 degrees Fahrenheit, indicating that a bioreaction was occurring. During the morning startup, the steam line was cleared of condensate and the steam process began. This video shows the draw of the waste prism due to temperature differential and the draw of the perimeter extraction wells. The steam is actually drawn into each injector as their valves are opened, indicating less steam at the end of the steam line. Settlement monuments were installed at various locations around the test cell. The monuments were surveyed by the City of San Diego several times during the pilot study. Most of the settlement occurred around the steam injectors. Red flags were placed into stress cracks in the cover soil that indicated that settlement was occurring. Over time, the red flags were observed to be in a line indicating a bowl shape, primarily around steam injector 2. This series of videos shows the settlement of the test cell over time. As you can see, the steam line was re-leveled periodically as the landfill surface lowered. Please note the thermocouple cables running along the steam line to the acquisition trailer. After 2 months of operation, a new and larger steam boiler was connected to the main steam line to accelerate the rate of settlement. The mounds of soil around the steam injectors were raised to insulate the injectors as the landfill settled. Please note the airspace between the steam line and the pipe stands. Extensions were added weekly as settlement occurred. As settlement occurred, additional soil was placed around each injector for insulation. Five-foot jack stands were installed to provide additional stability for the steam line as settlement became more rapid. The intention was to support the steam line up to a 5-foot elevation above the landfill surface. Once this was achieved, the blank riser injector pipe would be removed. The steam line would be lowered to the landfill surface and reconnected to the steam injector. Many more stress cracks were appearing almost daily. These cracks were tested continuously with the GEM 2000 for landfill gas emissions, with none detected. The settlement near steam injector 2 was over 24 inches. Towards the end of the pilot study, STI demonstrated that the extraction wells EW2 and EW5 could be converted to steam injectors since steel pipe is used in both devices. These two smaller boilers were used to apply steam to the extractors. They were placed in the center to simplify the piping for the water and the propane gas to each boiler. This procedure also helped to evaluate the use of steam hose instead of steel pipe as a steam supply line to the injectors. In future projects to cut costs and maintenance, steam hose would be buried within the cover soil for insulation. A 5-foot lateral steam hose would be connected from the steam supply line to the injector to allow for settlement. Upon completion of the pilot study, a follow-up PPT profile was performed to determine what effect the steam injection had on the waste prism. A PPT sounding was performed at the same locations prior to the study. The results were overlaid onto the previous soundings to observe any changes caused by the steam process. Some of the soundings did indicate waste with less density due to bridging from the thick landfill cover. Other soundings indicated increased density where the cover soil had settled. This data was also used to verify that there were no perched water layers in the waste prism. It was determined that all of the injected steam was converted to methane gas and carbon dioxide and extracted. While monitoring the extraction wells during the study, it was indicated that the methane quality started at 54% methane and increased to an average 62% in the test area, compared to a 45% average in the gas collectors and the rest of the landfill during the summer months. The pilot study demonstrated that steam injection is very effective in creating a bioreactor. The steam warms the waste instead of cooling it as water injection does. The thermocouples indicate that the steam moves in all directions, providing complete coverage of moisture. The study proved also that the extraction wells can be used to control the rate of migration of the steam through the waste prism by increasing or decreasing the amount of vacuum applied. It was also demonstrated that this process can use leachate and condensate as a water supply. The Miramar landfill is a certified ISO 14001 operation, and STI was able to operate within these and all regulatory agency requirements. We appreciate you taking the time to review this video, and we hope you found the information interesting and helpful.